Digestion, which is what we're doing today, chapter 23. And then we do kind of the second part of this chapter. There are two different chapters, but it's nutrition and metabolism. So that's a nice, easy, light chapter. And then after that, I think it's, what, reproduction? Lymphatics. So,
when are you going to post these grades?
what?
When are you going to post these grades?
Well, I'm going to get that this week.
Okay.
I will do it as soon as I can.
Okay.
I'll run them through the scanner,
Okay.
and I'll try to post them this afternoon for you.
Sounds good.
No
Thank you.
rush. Yeah, no, I'll put them in as quick as I can. I'm curious to see. So, let's see, what do we have left? Oh, what do we have left to do? We're doing digestion. We're skipping lymph and immune, I believe, in the summer term. And we do nutrition.
Wait, we're not doing that?
Yeah, lymphatics listed for the first syllabus.
Is lymphatic listed?
Yeah, and then we have digestion, then nutrition, metabolism, then lymphatics, and reproduction.
Okay.
I mean, we can skip it if you want.
Lymphatics is like a tiny little chapter.
Lymphatics.
We can skip it.
I think I see that.
It's like, yeah, a little 20 slides. So let's just skip it. So it's like 20. The immune chapter is big.
Where is it on this?
Okay, so let's skip
I
it.
think
So,
they
dropped
dropped, I think they dropped the immune chapter for summer.
Oh.
Which was a big one.
Yeah, I just had digest.
I have digestion, metabolism,
We don't
and
have
reproduction.
Lymphatics not on my syllabus.
Mine
It's
is.
not on mine
Is
either.
it really on yours? It's not on mine.
It's just not easy.
It was one of the downloadable chapters,
So
that was
so we
online.
have digestion, metabolism, and reproduction.
Yep.
That's all we got.
Yeah.
So, yeah, we have 3 chapters. And reproduction, we split it into male, female reproduction. Or chewing, that's voluntary. Once we swallow, all involuntary. We're going to talk about how are things moving, what kinds of secretions are involved in our mouth. We have saliva, we have hydrochloric acid, we have pepsinogen, we have our accessory organs, so we have our insulin, we have bile. So what kind of secretions are helping in digestion? And then what are we doing? We're digesting and then we're absorbing. So the digestive system is a disassembly system. We're tearing down the stuff that we're putting in. So that's what we're going to go through in this. In the digestive system, we call it the alimentary canal. Another word for that is the GI tract or the gastrointestinal tract. And then we have our accessory structures that help the digestive system. So in the alimentary canal, it's a tube from our mouth out, the rectum and anus. That's the alimentary. And then the accessories are all the outlying things. So alimentary, it starts with our mouth. We're going to put food in our mouth. And so the accessory things are going to be our teeth, our tongue, our lips. Those help us with chewing and eating. And then we're going to swallow. Once we swallow, everything from then on is involuntary. So we know that our throat is called our pharynx. We talked about that in the respiratory chapter. We swallow down the esophagus, goes into the stomach, that goes into the small intestines. There's 3 parts of that. And then it goes into the large intestines, and we'll label all parts of that. If it's not in that tube from the mouth to the anus, then it's outlying, and those are called the accessory organs. So the teeth and the tongue and the lips, it all starts in the mouth. We have the liver over on the side that has the gallbladder tucked up underneath it. The pancreas below our stomach, that's going to secrete insulin and glucagon. That's very important in our digestive system. And then the salivary glands in our mouth. So it first starts with secreting saliva, and that's the chemical breakdown of food. The teeth and the tongue are the mechanical breakdown, but we have saliva that's going to help chemically break things down. So let's take a look at what we're going to be doing this week. So this is our alimentary canal system, gastrointestinal system, digestive system, whatever you like to call it. So we're going to come in the mouth. We have the lips, the teeth, the tongue. They're going to help with digestion. Those are accessory organs. We have our 3 salivary glands. Those are accessory organs as well. Next to your ear, right through here, is the parotid gland. Have you ever eaten anything sour and you get that pucker? That's what that is. it contracts and then it pushes on the nerve that goes through there, and you're like, oh, you get that super pucker, like Sour Patch Kids, or whatever sour things you're eating. Lemonade sometimes, depending on how sour that is. So that's the nerve going through the parotid gland. And then we have underneath the tongue, so the sublingual gland, and underneath the mandible, so the submandibular gland. Those are our three glands that are going to secrete saliva. So instead of a neuromuscular junction, remember when the nerves talk to the muscles, we have movement, or the motor action is going to be some kind of action, or it's going to talk to a gland, and we're going to have secretion. Instead of movement, we're going to have secretion. So we're talking to the salivary glands. And the nerves that are talking to the salivary glands might be sight. We see something that looks really tasty, or smell. We smell popcorn, or pizza, or homemade bread, or cookies. And the sight or the smell of things are the sensory coming in, and we're seeing, we're smelling, we're like, ooh, the promise of food. And the motor action goes back out, and it talks to the salivary glands, and they start to secrete saliva. So that's a glandular thing. And we have the three glands there. Then we're going to swallow. So once we swallow, it's all involuntary now. We're going down the esophagus. We're going to come into the stomach. So now we're into the smooth muscle cavity, or category. Remember, smooth muscle lines cavities and organs. So esophagus, stomach. I'm going to talk about the different parts. We're going to transition from the stomach into this lighter color. That's the small intestines. And it has three parts over here. The stomach goes into the top part of the small intestines, and where it empties is called the duodenum, or duodenum is okay too, if you want to say it like that. And then we go into the first loopy part, which is the jejunum, and then the lower loopy part, which is the ileum. So these three things, duodenum, jejunum, and ileum, are part of the small intestines. So we leave the stomach and we go into the small intestines. Between the esophagus and the stomach, up here on top, and between the stomach and the small intestines are sphincters, muscles that close, and we're keeping that contents of the stomach in the stomach because it has hydrochloric acid, the strongest acid that is around, and it's on the pH of 1 or 2. So the stomach has certain tissues that allow it to hold and withstand that pH of 2. If that sphincter is a little bit loose, we get a reflux, so that's gastric reflux. The word for stomach is gastric. And if that contents refluxes up into the esophagus, then it burns because the esophagus is not lined with tissue that can withstand a pH of 2 of hydrochloric acid. So that's where heartburn comes from. So the heart sits right about here, and that's why we call it heartburn, or GERD, G-E-R-D, gastro, stomach, esophageal, refluxing up into the esophagus, gastro-esophageal reflux disease. Fancy word for heartburn. So what's happening is we have that sphincter up there on top that stays nice and closed, and it's just a muscle. And if it's slightly loose, that can regurgitate up, and this is why when we lay down, it backflows up in there, because when we're standing, we have gravity working with us, and the fluids are staying down. As soon as we lay down, that fluid can seep back up into the esophagus, so that's why people have heartburn much more when they're laying down. Or pregnant women, because the baby is pushing up, and all of that is pushing up into the esophagus. So that's GERD, and it's that sphincter right there. We call that the cardiac sphincter, because the heart line's right here.
Now, my uncle had surgery for his acid reflux. Would that be the site of what they're doing?
Yep, that's the site in there. Sometimes they'll go in and put mesh in there, just like with the valves or with vessels, how they'll put a shunt or a stent or mesh or whatever they're going to put in there.
Yeah, like the same thing like for a hernia, the same.
Same thing with a hernia, exactly. So there's a valve right there, that's called the cardiac sphincter. This is the liver and the gallbladder overlying it, and here's the pancreas. So that's what happens with heartburn. And then the same thing, when we exit the stomach, we have a sphincter down here as well, keeping the contents from spilling into the small intestines until we're ready for that to happen. So we need to have digestion happen before it goes down there. And that's called the pyloric sphincter. More on that later. And then we go into the small intestines, duodenum, the first part, the jejunum, and the ileum. And then we transition from the small intestines to the large intestines. When we transition over, so this is the ileum. The first part of the large intestines is this area right here, that's called the cecum, C-E-C-U-M. And there's a valve right there. It's called the ileocecal valve. And that stays closed until we're ready for the small intestines to pass stuff into the large intestines. So the function of the small intestines is absorption. We're passing food down, the stomach is digesting it, breaking it down, it's a storage tank. And then absorption doesn't happen until we get into small intestines. And it's like the kidneys, we absorb everything we need, and then whatever we don't need, we're gonna pass out, but instead of passing it out as urine, now we're gonna pass it out as feces. So the large intestines is largely just an elimination system. This is why you can live without a large intestines, and somebody will get a coloscopy, or they'll have the bag out here, colostomy, and it's just an exit route first step. So you do not have to have a large intestines. Life is much better and more comfortable and easier with the large intestines, but it's strictly for elimination. You have a little bit of absorption going on there, but it's mostly elimination. So again, there's a sphincter, the ileo, lower part of the small intestines, going into the first part of the large intestines, cecum. So the ileocecal valve. How about this little guy? What's he hanging down here? Appendix. He's tiny, isn't he? The variform appendix. Variform, it looks like your pinky. It's worm. Variform is worm, so it's worm-like. And it sits right down here. It is part of the lymphatic system, just like our tonsils. Stuff comes in, we trap bacteria, and we try to get rid of it before it gets into our system. Same thing down here, the appendix is part of the lymphatic system, so it traps bacteria, debris, viruses, whatever. And we try to eliminate it before it gets out into the rest of our system. So if the appendix gets enlarged, it's just like our tonsils. If it's doing its job, it's trying to destroy things. But just like our tonsils, if they become overloaded, then it just becomes a breeding ground for bacteria and bad news. And what would happen if that ruptures? Where's that stuff going to go? Everywhere. It's going to go back into the small intestines. It's going to go all throughout the large intestines. And all that bacteria is going to go all through the system and you become septic within 24 hours. So that's why we do emergency appendectomies. Or, if they're chronically having inflammation, sometimes they're like, look, we're just going to take that out. It's just causing a problem. Or if you go in and you're having an appendix attack and it hasn't ruptured, you'll go in and do it before it ruptures. So that could be an emergency situation.
Do they start throwing up blood because it's going back into?
Right. So if you start vomiting green or diarrhea green, that's an emergency 911 situation because it's ruptured and you have the pain and it's ruptured, so there's bile in there, there's feces in there, everything is just free willy all over the body. So, and the body can't overcome that. It can be very difficult to overcome that. So you get them on heavy duty IV antibiotics to try to get that bacteria under control. So that's why an appendix, a ruptured appendix, can be a life-threatening situation. So you try to get ahead of that. Then we go into the large intestine. So we start with the cecum, the lowest part right here, cecum. Then we go up the ascending colon, across the transverse to go across, down the descending colon. Then we make this S turn, that's called the sigmoid colon, and the rectum, and finally out the anus. So all of that, this big loop is the large intestines, and that's elimination. So we're getting rid of feces out of that. Small intestines, duodenum, jejunum, and ileum for absorption. Stomach is a storage tank plus a breakdown system, and then the esophagus, how it gets from the mouth to the stomach. Then our accessory organs are all the outlying things, not part of that tube. The liver, we have a great big liver here with the gallbladder tucked underneath it. Underneath the stomach, we have the pancreas. Over here on the side, we have the spleen. The spleen is like a recycler of red blood cells. So it hangs out over on the side there. And those are our accessory organs. So that's what we'll spend this chapter talking about, and we'll look at that in class. Questions so far? All right, so the digestive system is the GI tract. It's a disassembly system. nutrients become available to the body. And there's six essential activities. First, we ingest, we gotta get food in our mouth. And then we're gonna swallow, that's propulsion. Then we're gonna start breaking it down, it's the disassembly line. Mechanically, the stomach is churning, and it's mechanically breaking it down. Chemically, with saliva, with hydrochloric acid, we're gonna have pancreatic juices, we're gonna have bile coming in there. Small intestines is gonna absorb, and the large intestines is gonna eliminate. So here's our picture, these little blocks out to the side. First, ingestion. Then we have mechanical digestion. The teeth, the lips, the tongue, we're chewing, churning, we're breaking things down. That's beginning of mechanical digestion. Chemical digestion also because the saliva is breaking it down. Then we're going to swallow, that's propulsion. How we move things once we get into the involuntary, this darker line below, is by peristalsis. And peristalsis is a waves of contraction kind of thing that moves things through the smooth muscle. So peristalsis pushes it down the esophagus along with gravity, helps it move through the stomach, and then peristalsis moves it through the small and the large intestines. When you hear that rumbly, that's peristalsis in there, and you feel waves of contraction, that's peristalsis. Chemical digestion with saliva, hydrochloric acid, several things in the small intestines. And then we're absorbing things, and we're moving back and forth, just like in the lungs. We're carrying things, and then we're going to go across the intestinal lining and go back out into the blood, or vice versa. And then we're going to eliminate things through the large intestines, and then finally out the rectum and the anus. So here's what peristalsis looks like. Here comes something in the smooth muscle. We have stretch receptors in there saying, hey, there's stuff in here, it's time to start moving. And they're going to contract and squeeze that down, contract and squeeze that down. And we also have a segmentation portion of that. We take 2 steps forward and now 1 step back. And then 2 steps forward and 1 step back. That's part of the breakdown process. So it's churning and moving and churning and moving and churning and moving. And this doesn't go straight through unless there's E. coli or something in there. And then sometimes it goes straight through. Because it goes through this process and the body says if some kind of E. coli or salmonella or something comes on board, the body's like, whoa, we don't want any part of that. And you'll just have like immediate diarrhea. The body's like, we don't want that, or vomiting. It recognizes that, so it doesn't even take time with this, and stuff just comes right out of your system before you throw that. So that's a protective or defensive mechanism. It can take anywhere from 30 minutes to a couple hours. So what is regulating? Now we're totally involuntary, so here's our receptors, chemoreceptors. We've talked a lot about those. They're monitoring what is the concentration of stuff, osmolarity, pH, what's our pH in there? What do we need? Do we need sodium? Do we need potassium? Do we need amino acids? Do we need carbohydrates? What do we need? So that's the chemo, monitoring the chemistry of what's in our system. The mechanoreceptors say, oh, okay, we are eating and it's time to stop eating because you're full. Stretch receptors in the stomach. This is why, and in the intestines, they sense the food's in there, time to start breaking down, time to start absorbing, time to start eliminating. So mechanoreceptors is why you should eat slowly. We've heard about drink a glass of water before you eat because it fills up your stomach. The mechanoreceptors stretch and they say, hey, you're full, you don't need to eat that much. So this is why that's one of the techniques when you're dieting is to drink something, drink a glass of water, because that fills up your tank. And then you get that stretch receptor. You might still be hungry because water's not going to fill us up, but the stretch receptor says you're getting full, your tank's halfway full. If you're eating very, very quickly, it takes a while for those receptors to monitor. So I have 2 boys. I've seen incredible feats of eating quickly. And you know, the kids will come over, you'll order 2 or 3 pizzas, and they're all standing in the kitchen. And so you learn, you got to get at least 2 pieces for yourself before you put that box out on the table. And then they all come around, they stand around, and they chow down. You're like, what happened? And they just scarf it right down, right? Like, well, we have plates, you can sit. Well, why would you want to do that? Boys are not interested in that at all. And then you go over to your girlfriend's house that has only girls, you're like, wow, this is totally different. They have plates, not paper plates, real plates, and napkins, and forks, and knives. You're like, it's pizza, what are you doing? And they're like, oh, get a pencil for a manicure. So I go for crying out loud, just eat the pizza. So it's a whole different story between boys and girls. I witnessed it. So, but they eat really fast, and then they're like, or we do this on Thanksgiving, right? It's all there, and it looks so good, and you don't want to stop. And then afterwards, your stomach just keeps stretching. Oh, why did I do that?
I think it's worse if I like starve myself all day too,
Right.
because then like my stomach is shrunk down and then,
Yeah, and then you're starving.
and you're starving.
And then you eat everything, you're like, oh, it's so good, and then 20 minutes later, you're like, oh my God, I should have stopped 10 minutes ago.
Yeah.
So that's those stretch receptors in there monitoring. So if you take your time and chew and eat slowly, your digestion and your receptors are keeping up with each other versus just slamming food in there really quickly. And then we know other foods expand too, like when you eat, like rice and pasta, you're like, oh yeah, I feel pretty good. And then it just feels like it just keeps growing and growing. You're like, oh, just halfway through. So mechanoreceptors definitely involved with that. What about muscles of the digestive system? So muscles themselves are responding. They're contracting as we're swallowing. The muscles are contracting to down the esophagus. The stomach has 3 layers. They go in a circular motion and a longitudinal motion and on an oblique angle. And so it's more like a twisting, churning kind of action. They contract in all 3 directions, and that's part of the mechanical breakdown that's going on. And then also we're going to have secretions, the salivary glands. We see food, we smell food, start secreting. The stomach, here comes food, start secreting hydrochloric acid. Fatty foods come on board, the gallbladder says, oh, you better start secreting some bile. Here comes starches, start secreting some insulin. So we have all of these things responding to the stretch receptors. And then how is it mediated? Locally, we call that enteric, what we were just talking about. We have smell receptors, stretch receptors. So locally, they're monitoring what's going on in their specific part of the digestive system. And then, of course, the central nervous system, the brain and the spinal cord, are going to receive stimulus and send out nerve actions. So we have local stretch receptors, or movement receptors, mechanoreceptors, and then the brain is telling the body what to do. So here's the big picture. We see things, we smell things, we taste things. That's the stimulus, goes to the central nervous system, and that sends it down the long reflex. Stretch receptors are activated locally, and then the effect start secreting, salivary glands, bile, pancreas, start contracting smooth muscle, and then we have that response. Or we have that local or enteric system where the stimulus comes in, the chemo, osmo, and mechanoreceptors are responding to that. They send it to the central nervous system. So the short system kind of takes a quick loop around. The long system goes all the way up the chain and comes back down. So we have short ones and we have long ones. Yes?
So for instance, somebody that's on a feeding tube that doesn't get, they don't have the reaction to the smell or the taste,
Right.
because they've been on that, would you still have that, would they have different receptors for?
So they're just gonna bypass the upper portion of it.
Okay.
And then they're still gonna have the stretch receptors. And then once the food comes on board, we're still gonna start secreting.
So even if they were to like smell like whatever, if they never like want to.
Right, yeah. So they'll still go through the long system, but it'll push them through the short system as well. So just like other ones, we have short routes and we have long routes. And then getting into what kind of tissue makes up the alimentary canal. We have 4 layers. So what's the word for that? Layers, stratified. So we have 4 layers of the esophagus because the esophagus is withstanding friction. Food is coming down. So we're going to have stratified squamous in there. And then same thing when we're going out, the rectum and the anus, stuff is coming out, so you want to have layers in there to withstand that friction, so stratified squamous there as well. If we look inside, going from the lumen, from the inside, the opening outward, then we're going to look at, the lumen is the opening. We're going to have the mucosa, the mucus layer that's lining the opening. Then we go out a layer, the submucosa. Then we're going to have the muscular layer. And then finally, we're going to have the outer layer, whatever tube that we're looking at. So here's our anatomy of it. The lumen is the opening, so we're inside the esophagus or the digestive system. And then that layer just outside of that would be the submucosal layer. And then we have, so the lumen is going to be lined with the mucosal layer, so we can secrete mucus and it can be lubricated. And then we have the layer outside of submucosal. Then we have to have muscles, so we can be contracting. And then serosal is that outermost layer. So like remember our layers that goes over stuff? That's the outermost layer. So we have a tube, but it's not just one tube, it's an opening lined with mucus, the mucosal layer. Then we have a layer out of that, and then we have a muscular layer, and we have the outermost layer. So just like all the other things, it's never just one thing, it's lots and lots of levels or layers. So the two major intrinsic nerve plexuses, so how are we talking to this through the nervous system? Submucosal layer, so we're talking to the glands and the smooth muscle, we're saying start secreting the mucus so that you can lubricate whatever hollow organ that you're in. And then muscle layer, so we're talking to the mucosal layer, we're talking to the muscular layer, and we're helping, if we're talking to the myenteric, then we're talking to the muscles, and that's motility, peristalsis. Also, there's going to be segmentation and peristalsis, so the nervous system senses through the chemoreceptors and the mechanoreceptors. It's sensing that there's something in the tube, so it says, well, let's start moving this stuff, segmentation and peristalsis, so that's an automatic thing. And then, of course, the central nervous system is receiving that stimulus, and we're going through that same old reflex arc. Stimulus in, up to the brain, motor back out. So what are we going to do? We're going to secrete salivary glands, gallbladder for bile, stomach for hydrochloric, pancreas for insulin. So what's going to be the motor action? It's either going to be segmentation and peristalsis, movement of the tube, or secretion of whatever gland is. So we still always have the central nervous system, the brain and the nerves talking to something. What is it going to do? It's either going to secrete when we talk to the glands, whichever gland, or it's going to do movement, physical movement, segmentation, peristalsis. So we're talking, telling it to secrete lubrication, or we're talking to the muscles and say, let's move stuff. Does that make sense? All right. Questions over that first part? All right. Pretty basic stuff, huh?
Yeah.
No fluid dynamics here. Yay. All right, let's take a trip. Let's go through the system. So we start with the mouth. We know the word for mouth is oral or buccal. Buccal of the cheek. Remember our buccinator muscle helps with chewing. So the mouth is bound by the lips, very important part. Very important part. No, I'm fine, thank you. Very important part. The cheeks maintaining boundaries, lips maintaining boundaries. The palate, the roof of our mouth, our palatine bone, remember that. And our tongue. So they're all helping contain things. And it's a contiguous thing with the pharynx. So all of the lining is going to go down into the throat. And we're at the back of the mouth, so we call that the oral pharynx. It's built to withstand abrasion, stratified squamous. Remember, lots of layers of flat cells. We have the gums, the hard palate, the soft palate. They're all keratinized, lined with lots of keratin cells so they can withstand that friction. So that's the mouth.
What is dorsum?
Dorsal back, top of the tongue, back of the tongue, top and bottom of the tongue.
Okay.
I'm sorry, you said keratinized or withstand friction in the basement?
Keratinized, hard, scaly, thorny, corny, all of those words go with keratin. So remember, our skin is made of keratinocytes, so they can withstand. Same kind of stuff. And we have motility in the mouth, so we're going to break down food, chewing with teeth and tongue, and we have chemical. We're going to mix it with saliva. So we used to do a lab that was fun, where somebody would chew up crackers, and we would have saliva mixed in with that, and then we could see how quickly it broke down versus just crushing up crackers. And the breakdown happened much quicker with the saliva in there because we have enzymes, and remember, enzymes push reactions to happen. So we would look at, we put a little piece of liver, I think, and we would see how quickly we could denature it, because it's protein, it's meat. We put it under the flame, and we would see how quickly it could denature, and then we would do the cracker experiment with just crushed up crackers versus chewed up crackers, and how quickly those could decompose. So we used to do an experiment with that. I don't know why they eliminated that part of it. But it broke down much, much quicker once we had salivase in there, ASE, which is an enzyme breaking down stuff. So much quicker, much easier to break foods down when you have that enzyme there. Which kind of goes back to your feeding tube question is, are they breaking down and absorbing? Because you're missing that first key step of putting that enzyme in there to break stuff down.
Would it be the same for someone that has like an abdominal?
Yeah,
Would they
but
still saliva?
it's mostly liquid,
Okay,
so we don't have as much breaking down to do,
okay.
but they are missing some of those key steps in there.
Would the saliva affect like would they get acid reflux and stuff like that?
Yeah, sure.
Okay.
So here is our oral cavity. You don't have to know all the stuff on here, but this is the cross section that we look at in the lab. So this is sometimes what they'll ask, what is this? These are your lips up front. What's this big thing here? Tongue. They ask that a lot on the lab test. People miss it all the time. They're like, I don't know what that is. It's a big muscle. It's the tongue. So we have our lips, we have our teeth, we have our hard palate, the palatine that makes the roof of the mouth, and then the soft palate towards the back. And the uvula is the hanging down thing when we say, ah, that's the uvula. And the purpose of that is it closes, so when we're eating, foods and liquids don't go into the nasal cavity, you can open out. However, we've all probably had that happen or witnessed that. You're laughing, you're talking, stuff goes up and comes out your nose, or you laugh and you inhale it, milk comes out your nose, or we see this thing on TV where people put like noodles in their nose and they'll pull it through because it's a clear pathway unless the uvula closes it off. So that's how we get from the nasal to the oral cavity there. Has anybody ever done a neti pot before? Yeah, so it'll come out your mouth. It's nasty. Or if you're
It
ever,
works so well.
it works so well. A neti pot, N-E-T-T-I, neti pot.